then we'll go into the accelerated devices. And at the end, I thought I can walk you through some demo sessions with the tools which we use, mainly on the Databricks side and the Palantir. Those are the two main softwares we have been using. Unfortunately, I cannot share whatever we are doing within BP due to the policies and the security reasons, and I cannot show any kind of IPs which we are developing within BP. So whatever I'm going to say, it's more like a generic one. So sorry for that, but let's start dive into this. Yeah. Give me a second. Yep. Yep. So yeah. So AI, as we know, AI refers to it's like a computer system that can perform tasks which act like a human intelligence. And these tasks, it can include various things like reasoning and problem solving and learning and natural language understanding. So, for example, learning is more like AI can improve their learnings through the experience, like machine learning. And reasoning is more like it can analyze the data and it can recognize the pattern and make some informed decisions around it. And adaptability is more like AI can adjust to the new data or the new environments, and we don't need to explicitly go and program something on for the adaptability. And automation is more like we are just make the task more repetitive with a higher efficiency. And whatever I depicted here is more like machine deep learning is like a subset of machine learning, and machine learning is like a subset of artificial intelligence. Yep. And there are a few AIs in actions like a virtual assistants, like how we have in the phones. If we are using iPhones, then we have Siri, or you can see some Alexa devices or Google devices at home that provides a virtual assistance. And we have a lot of image recognition softwares these days, and recommendation systems like if you watch some cinemas in Netflix or Amazon, you'll be getting recommended movies, or in the Amazon, you'll be getting recommended retail shoppings. And autonomous vehicle is one of the critical AI part which everyone is trying to address. And we are here about Tesla. Tesla is trying to do a full self-driving, and they are trying to be leading against on solving this autonomous vehicle use case for AI. Yep. And so next is all about, sorry, 1 second, go back. So, so how does AI works? So normally AI, the key important part is the data. So the data can be of any different format. It can be of speech, it can be of text, and it can be of image, or it can be any context around what is the data is all about. And once the data has been fed into the system, it goes through the data processing where we have algorithms and rules. It's more like it interprets the data and it makes some predictions, or it can act on what is the input has been provided to that. And the outcome, it's more like when they develop the solutions, it's more like it's looking for a success or failure, and the success and failures are being measured. And if it is not meeting the expected output, then it goes through the assessment cycle where we'll be reanalyzing and doing a discovery and having a feedback loop around it. So it's more like this and then the adjustment can be made on the algorithms or rules or on the data side if there is an issue. So this is more like a feedback system. It'll be repetitive, and it goes through the process again until we find the desired output has been achieved. Yep. So this is how the whole the simple AI system has been developed, and it's been following through this channel. Yeah. And next thing is all about key components, what we see in the AI. The main thing is the data. The data plays a major role. We need enormous amount of data to run the AI model. We cannot run the AI model and make something meaningful out of it using a small data set. So always there is a large volume of data is required. And the next part is like AI software and AI hardware. These are the three main components we are seeing. So AI software, it's more like it provides the algorithms like machine learnings, neural networks, and deep learnings, those kind of stuff. And AI hardware that provides the computational power to run this process. Since we are working on a large volume of data, we need to have an efficient underlying hardware to be available to run the models and get a meaningful output around it. Sorry. So how does AI software works? Is sorry, that's great. Yeah. So AI software, as I mentioned, like it's a collective applications we can refer. Like it can be of many things, but I just listed on few things for an example and understanding. And mainly machine learning we talk about. It's like an AI applications which automates and improves the experience and mainly it's been for an explicit programming, so users can write their own machine learnings and run through the software. And deep learning, I think, as I mentioned, it's like a subset of machine learning. So it's more for processing data with with the help of an artificial neural networks. So neural networks, it's all like more like a loosely coupled model, and it act like a human brain. So I'll talk about deep learning and neural network in the next slide in detail. But for now, I'm just listing down there are different elements of AI software is available. And NLP, this is the famous buzzword we started hearing these days. It's more around natural language processing. It allows the computer to act like a human, and it provides like applications like chatbots. We use ChatGPTs and language translations, and it act like a voice assistants. Like these days, if you call someone in the bank or if you try to reach to the customer center, it's all been fully automated and it's been developed using NLPs. And computer visions is like so it's more like interpreting the images and tables, graphs, and PDF pictures. This is mainly for facial recognitions and autonomous vehicles, and those areas we use computer visions. And one thing, yeah, cognitive computing is more like it's like a human kind of thought process. Like so it try to interact between the humans and the machine by understanding what the human language is, by understanding the human language and the meanings of the images. And the one thing I haven't mentioned here is all about robotics. So robotics is involved. It's more like a designing and building and a machine that can carry out the physical world. So the main role in AI robotics is a combination of all these AI softwares. It's more like you can combine machine learning, you can combine computer visions and control systems, and it can perform any kind of human related jobs like assembling in the warehouse, or it can do surgeries, or it can do the explorations. Mainly in the refineries, we have to explore in the wells and subsurface areas where like we go and find out whether the oil well is there in the deep sea, or it might be in a deep land space. So most of the exploration these days it's been handled with the help of robots. So yeah, this is where the software has been used. Next thing, I'll deep dive into deep learning and neural network. Sorry. So
ஹலோ
yeah.
மேம் சொல்லுங்கப்பா. நல்லா இருக்கேன் மேம், சொல்லுங்க. எல்லாம் முடிஞ்சுதா? சூப்பர் சந்தோஷம்.
Sorry, someone, can you go on mute?
இவன் இஷ்டத்துக்கு போட்டு வச்சிருக்கான். நம்ம இன்டர்னலும் பார்த்து எக்ஸ்டர்னலும் பார்த்து ஒரே நாள்ல ஒரு ஃபேக்கல்ட்டிக்கு எனக்கு இன்டர்னலும் போட்டிருக்கேன், எக்ஸ்டர்னலும் போட்டிருக்கேன் யூனிவர்சிட்டில இருந்து. ஆண்டர்பிரினர் கூட ஸ்டாஃப் இல்ல மேம் இந்த வாட்டி. இங்க எல்லாருமே நல்லதா எனக்கு யூனிவர்சிட்டி எனக்கு ஃப்ரீயா இருந்தாங்க. நான் போன மண்டே எனக்கு இங்க இன்டர்னல். ஆனா எக்ஸ்டர்னல் ஆர்டர் இருக்கு. இது என்ன ஒரு லாஜிக்னு எனக்கு புரியல. சரி பாப்போம். ஆமா.
Sorry, I'm muted. I'm hearing the external sounds. Yeah. Yeah. So diving into deep learning, sorry. So yeah, deep learning. It, as I mentioned, it's like a subset in machine learning, and it's more like deep learning differs from machine learning. It's whereas in the machine learning, the human has to interact like. Whereas in the deep learning, it's more like unsupervised learning. It can learn on their own. So mainly the deep learning algorithms is being handled on the unstructured data, and we no need to unlabel the data. Whereas when we develop the machine learning algorithms, usually the human labels the data and mark it more readable by the programs. And always there is an intervention is required if the data is not in the same format or the labeling is not done correctly. However, deep learning can it can label the data, and it can make the program more readable. So there are deep learning works like association between the various points in the data sets. So instead of human intervening and shifting through the data and labeling each data points, it can act like an algorithm that can attribute each data point on its own. So this deep learning is being started long back in 90s, in early late 90s, but the problem is like we couldn't use it much because there was a lack of computation power. So but these days the computation has been increased. That's why we started adapting more towards on the deep learnings. Yep. And sorry. Yeah. So neural network are currently used to deploy. Sorry, neural network is nothing but it's used to deploy the deep learning solution. The concept of deep learning, it's more like closely mimics like how the human brain works. So the human brain is a collection of a lot of neurons, and it's more like the same way the deep learning also works. Like it worked like a artificial neural network. So we call it as ANN, and it consists of many layers of neurons to process a large amount of information. So for example, in the human brain, we have 100 billions of neurons. So the deep learning and the implementation of deep learning through neural networks acts similar to that. Like it'll be like a mimic of that. Like you'll be having n number of artificial neural network, and that handles a large volume of data. So so the main thing what we are seeing is like always the AI needs a training data set, and it trains the data and the models using the training data sets. And once the training is done, it can be applied on the testing data sets. So what was happening before is like whenever we tried to use the AI models before, like a deep neural network, it was like a black box because we get an output. For example, here the cat image has been processed through a neural network, and we got the output as cat. In those days, the problem is like the AI is not going to tell us, or the algorithm whatever we have used is not going to explain us how they have arrived at these solutions. Yeah, which is like which is like a little bit unusual, right? Like if you're not able to find out how the solution has been arrived, we cannot completely rely on the AI models. So this has been improved quite a lot. In these days, how it works is like, for example, if you are processing an image like cat and it goes through a neural network, it will generate a heat map, and this heat map will provide a predictions as an output like a cat, but this heat map will visualize and then shows like what are the input variables have been used. Like for example, here a lot of pixels has been used, and 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 here the main thing is like it's telling us like the cat's ears and nose are being used to achieve the results. So whatever in these days we are developing through the AI, it's telling us like it's more safe and and providing a relevant prediction techniques. So this was been missing before. This has been evolved a lot in the recent days. Yeah, and I just want to highlight two main neural network APIs which we are using. One is the Google's TensorFlow. So TensorFlow has been developed by Google, and it's an open source. And everyone these days, when they want to implement a neural network, they'll go with Google TensorFlow or the PyTorch. So TensorFlow is like a Python based, and and it's portable. It can be portable to different languages as well, like Java, JavaScript, and C++. And PyTorch is mainly developed by Facebook, and then they made it like an open source. So and a lot of companies they are using PyTorch like Twitter and Salesforce, and also it's been built based on Python, and both all these frameworks are easier for implementing the neural networks. And in some cases, TensorFlow might be efficient when you compare to PyTorch. It depends on the use cases and how we apply and then train and then see the results. Yeah. So I've covered the AI software. I'm just moving on to the AI hardware part of section. So AI hardware is like a specialized equipment. It helps to run the AI models more efficiently. Um, but there is a history behind like initially when we tried to run the AI model, it was not efficient. So if you see the history, like if you see the history, like in early 90s and 50s, we started using AI algorithms, but that time the device like IBM provided support, like they have IBM 704, which helps in running some of the AI programs like Logic Theorist and General Problem Solver. And later in 1980s and 1990s, we started using more powerful microprocessor. So and the main evolution started happening after 1977. Like IBM has provided a chip called IBM Deep Blue, which helped in trying out AI more efficiently. Like I think they developed a program for a chess championship, and they tried to run it against that time there was a champion called Gary Kasparov, and they demonstrated like how the AI program can efficiently play against the person and how it can strategically make the decisions and move things. So the main evolution started happening in 2010, where the advancement of GPUs and all the AI hardware related accelerator devices started coming in, which has revolutionized the AI part. Sorry, 1 second. So there are a lot of AI hardware devices. We call it as accelerated devices. The main difference for AI devices and the AI hardware is not like when we say the hardware, it's more we are referring to the general hardware which we are used in our normal personal laptops or in the industrial machines like CPUs, RAMs, and things like that. That's not been developed specifically for running the AI part of things. So later we started using something called, all these are all, I've listed on few of them, but there are a lot of things, a lot of AI accelerated devices are available. So the main things is all, we call it as GPU, graphical processing units, So it's mainly for high parallelism. So if you want to accelerate the creations of images, videos, and visual contents, that's where the GPU started. Like a lot of graphic companies, they were using GPUs for building the video games and visual applications. And later, it's AI started using GPUs. The main advantages of using GPUs is like it does parallel processing. Like GPUs can execute thousands of tasks simultaneously. It acts like a matrix multiplications in AI, and it has a high throughput, and the memory bandwidth is faster. And there are a lot of specialized GPUs are available in the market. I think NVIDIA is the company which is dominating in serving the GPUs. Yeah, and the next one is TPU, Tensor Processing Units. It's one of the AI accelerated chip designed by Google. So it's mainly for performing the machine learning task, mainly designed to build the deep learning models like TensorFlows, as I mentioned in the previous slides about the neural networks. So the main use case of TPUs is like deep learnings, and for NLPs, they're using TPUs, and for image recognition and recommended systems, they're using TPUs. So it provides a low latency. So it's used in many applications like voice assistants and mainly for image classifications. And GCP, the Google Cloud platform, they use TPUs as well for their efficient way of storing and processing the data. And NPUs are neural processing units. It's a specialized processor which has been designed by Apple. And when I say Apple, it's not only Apple. There are other companies, they develop NPUs as well. But as an example, I'm saying Apple is also providing NPUs. And there are industries, they lead in these hardwares. It can though so some of the hardwares, it'll be led by NVIDIA's and AMD. Some of the hardwares, the leading might be by Apple or Google. So mainly NPUs are used in facial recognitions. Like for example, in Apple, we have the Face IDs, right? So that's been recognized using these NPUs devices. And like voice assistants like Siri, or in Google, it's Google Assistants. Those are all does helps. Those softwares can run on the NPUs. And edge computing. So NPUs also helps in the edge computing, like we have the cameras, smart cameras, and sensors. So those are all some of the applications that can be make use of NPUs. And mainly in autonomous vehicles, NPUs are being used because it helps in object detection, and it helps in navigation, and it helps in decision makings. Yeah, and these days, augmented reality, virtual reality, like uh, the Apple provided the AR devices, those things are all being using NPUs. It's not only NPUs, but they use quite a lot of AI devices, but NPU is one of the key element in recognizing the images. And FPGAs is like a field programming gateways. It's like a it's like a software that's not been specifically designed for one specific criteria. It's more like it can be configured and then it can be reconfigured. So whereas like the next one, we call it as application specific integrated circuit. It's mainly specifically designed for handling certain applications, whereas FPGAs is more like a custom. So you can write a chip level coding, and you can make the chip to work the way you want. Like you can run whatever the applications you want to configure, and then you can reconfigure it. So it's more like a custom friendly. It's more for programmable kind of things. So it mainly there are few certain industries they use, like in the telecommunication for 5G networks, and for automotive industries they use as well for sensor fusions and image recognitions. And in the aerospace and defense, they have these FPGAs because they want to design their own way of handling things. So this is very helpful in that space. And some of the medical devices, they use as FPGAs as well, like for MRI and ultrasounds. If they require real-time signal processing, they are writing the specific configuration softwares on FPGAs. And the last one is application specific integrated circuit, ASAC. As I mentioned, this has been created for a specific task or applications. So it's more like the general purpose, like GPUs, ASAC are like a custom built. So it's more like perform a narrow defined function. So if you want to tackle one specific functioning part of it, then that's been designed. So mainly when I explore, like it's mainly used in cryptocurrency mining. So for example, in Bitcoin mining, they use this ASAC devices. And there are few consumer electronics they use, like Apple uses for their AirPods. They use a H1 chip, which is of ASAC. And some of the medical devices and automotive systems, they use ASACs as well. And moving on to the next slide. Yeah. So the next one is about, so we listed on what are the accelerated hardwares or accelerated devices are being used and why we need AI accelerators. That's the next question comes along, right? So in the traditional CPUs, the problem is like it's more of energy efficiency. And so it trades off the energy efficiency for versatility. So like it cannot do much. It's more around energy efficiency side of things. Whereas the special purpose, the GPUs things, like the AI accelerated devices, which we have discussed now, that trades off versatility for energy efficiency. It's more like AI accelerated devices are mainly designed to minimize the memory and offers larger on the chip cache and include dedicated hardware to accelerated features like matrix computations and those things. So if you see on this diagrams on the left hand side, we have put the CPUs. These are being developed for a very general purpose. So as you can run only arbitrary code on them, like you cannot run multiple things and on the CPU side. Whereas so you can use them to perform any task that a dedicated chip does from graphics. So whereas where we are marked as AACC on the other hand, these are all can be capable of handling graphics, audio processing, and machine learnings. So it's more like an energy efficient side, like it handles on a very specific fixed functions, so it's more efficient. So why we are calling as fixed function is more like because they are developed to do just one things or few things, and it's more programmable. And for example, in the noise cancellation processor in your headphones, it needs to be very highly energy efficient because it needs to have more extended battery life when we use headphones. So in those cases, then they are using these kind of AACs devices to maintain the energy efficiencies and things. And I mentioned about AWS Inferentia. It's one of the Amazon chip they are using in the cloud for their cloud management. So why, as I mentioned, why do we need the special AI accelerators? It's all like it's mainly developed to handle the performance of AI workloads. So the traditional CPUs, it cannot handle these kind of heavy AI complex models running on it. So that's why we went ahead and then started using accelerated devices. So the main things, it's more like a high computation it needs. So as I mentioned, we have gone through the AI task. It's more like a deep learnings and neural networks, right? So it has to go through a large volume of data and it runs through large volume of neural networks and calculate the calculate things more simultaneously. So it needs more computations power. So mainly for high computations and parallel processing. So for example, we use ChatGPT, which uses GPT-4. It can we can post an image and ask him to recognize the models as well. So for all these things, we need a high computation requirement. And the other thing is about parallel processing. So traditional CPUs is more like a sequential processing. So it can process only one process at a time. So it has a limited number of cores. Like for example, you'll be having 4 to 16, depends on the CPU capacity. So it can process only one in the sequence manner. Whereas the GPUs, it has thousands of cores and it can handle execution of multiple tasks. And more significantly, and then it will speed up the modeling, trainings, and inference. Yeah. Energy efficiency. There are specialized AI accelerators are designed to execute the AI task more efficiently. So mainly for mobiles and edge devices where the battery life is concerned, we need more energy efficient accelerators. And then data centers where we spend quite a lot of energy cost on that. So that's where Google TPUs are being used. Like they are low power and it can do a lot of matrix operations and reduce processing time. Like so AI workloads uh, provides a lot of time consuming things like if you use standard CPUs, whereas if you are running on the AI models on the neural networks, and if you want to drastically reduce the processing time, then that's a key need for going into this AI accelerated devices. So we cannot train a large language model on a CPU. It can be trained, but it takes like a week's time to run the model on the CPUs. Whereas whatever we are trying to do now, we want the results to be seen very quickly in the real time. And and as I listed down, there are a lot of AI accelerated devices that have been developed because it's been performing a specific operations for AI. So for example, TPUs, NPUs, and FPGAs, all these are all, they have their own specific tasks to be accomplished. So all these can be combined in a device and it can run parallelly in handling all these devices. And the main thing is all about scalability. So when we handle AI models, it has to be scalable. So we'll be running the models in a large scale. So that is one of the reasons all these accelerated devices have been used. And the last thing is about real-time processing. So as I mentioned, like autonomous vehicles, which we are trying to work on, it's like a full self-driving where the data comes on the real time and the decision has to be made at the real time as well. So and the robotics as well. The decision has to be made very immediate, and all these edge AI computings where the decision has to be made more at the real time. So all these reasons has been applied to move us to use the AI accelerated devices. Yep. The next thing. So the key components of AI hardware, like similar to the normal hardwares, we have processor, memory, and interconnects, power supply, and cooling system. The way it works is different, but all the key components might be looks very similar. For example, processor, uh, when we have CPUs, right? Similar to that, the AI hardware devices will have GPUs and ASICs and FPGAs, all those devices, all those kind of processor. It depends on which kind of AI model runs. It can be used and programmed to use that. And memory, it's more like as we know, like RAM and storage. But in the AI hardware, the RAM will be more because it has to handle large volume of data sets. And storage is more like we have hard disk drives and solid state drives. So more for SD, solid state drives are more preferred for AI workload because of faster data access. And and interconnects is like it's like transforming the data between different components of AI systems. So for example, if you are connecting. So we need a high speed interface to connect the data. So for example, in GPUs, there are the GPUs has to be connected to the motherboard, and it's all has to be passing the data very quickly. So that's where so NVIDIA provides NVLink, I think. So they provide quite faster interconnects between the GPUs and multiple GPUs in the motherboard. And power supply, yeah. Power supply, we need to have an efficient power supply. Like a hardware is more robust, so the power supply units has to be more stable and reliable. Um, so there are two main things has to be considered as part of power supply: the voltage, how much high power and the processor can be consumed. So and how efficiently it can reduce the energy when it consuming it. So those things are all being key components in the hardware device when they design it. And the cooling system. So cooling system is a vital important things because it when it runs a large model, the temperature on the hardware device will be high. So they need a cooling system to control it. So in normal cases, like we have a air cooling, like they'll be using a fans and that will run continuously to reduce the temperature if it goes high. But it is cost effective, but it's more like it'll be struggling when there is a high heat loads are there. So they use some liquid as well to transfer the heat away from the components. So more cooling liquids and cool quieter than so they use air cooling kind of things as well. And they have hybrid coolings, which is more like using air cooling and the liquid cooling together. Yeah. And as I mentioned, like there are a lot of A hardware manufacturers in the market. Like some of them I've listed down who are industrial leaders like NVIDIA, AMD, and Intel, Google, IBM, Amazon, and Microsoft. Each of their these companies they have their own versions of AI accelerated devices and chips, and they have their own industrial lead on certain devices. And like for example, if you take Google, they have the TPUs which they are using in the Google Cloud, and Amazon they are using Titanium chips which they are used in AWS Cloud. So like that, IBM they have their own chips. So it's more like in the market, like how we are choosing the chips. It depends on the use case and applications. Yeah, and the last thing I want to say, sorry. Yeah, A hardware device for different applications. So as I mentioned, like AI devices have been used widely. So some of them I've listed like in the data centers and cloud computing. So as you know, like we have been moved to cloud computing. Like it's all the datas are residing in the cloud and the computations are happening in the cloud. So all these powerful GPUs and TPUs and AI accelerated devices have been utilized in the data centers and the cloud. And edge computing, which is one of the key thing, like as there are a hardware which is needed for edge computing that's been like FPGAs I mentioned. So NVIDIA provides something called Jetson Nano. They use they're more used for the edge case applications, and it runs real-time AI processing capabilities. And we are using all these hardwares on the autonomous vehicles. We have AI chips with high processing powers, and NVIDIA Drive is one of the chip that has been used by Tesla for doing their full autonomous self-driving. And robotics, I think it started developing. So all of the companies they are started focusing on developing robots, which is just more like can be used in the warehouse and the industries, and it can also evolve and it can act like a human as well. So there are a lot of NVIDIA chips are helping in developing the robotics as well, and healthcare, medical, and IoT devices, all these places, and gamings and entertainments, all of the areas we have a lot of AI hardwares running. Mainly, whatever I've listed down, those are the key important AI processors which we are using these days, but there are quite a lot, and they are reinventing as well. So when the times goes, we might be seeing new chips comes along in the market. Sorry, to the next one. Yeah. So I just want to mention about there are a lot of industrial uses of using this AI hardware. Since our topic is more towards software and edge computing, I just thought of touch base with this edge computing, but you'll be having other workshops where they might go deeper into this. So I'll tell at the high level, and then you can take it from here. Yeah. So edge computing is more like we capture and process the data very close to the source. Like instead of getting the data into the cloud and processing it, there is a latency. So if you want to make a quicker decisions, then we want to run the computing very close to the devices. So it's more like where the data has been um, set locally, and then instead of in the cloud and central data center, when the data goes to the cloud or a centralized data center um, like a on cloud or on premise, the latency is higher because the data has to be traveled from the devices to that locations. So those transit cost and real-time feedback may not be available. So that's where we all moved into edge computing. Like if there is a need for a quicker decisions and quicker things to happen at the real time, then edge computing plays a major role. So the as I mentioned, it's all I already mentioned about the low latencies and improved security. It's more like if you have a sensitive data and we don't want to take it to the cloud and process it, and we want the decision to be made immediately, then this can be achieved through edge computing. And since the data is not being transferred, there is the latency is less, so the transfer cost is less, so it provides lower cost. And edge computing, there are places it helps when there is no need for internet access. For example, in energy, oil and gas, what is happening is like we have a lot of rig wells which runs on the deep ocean, and they are not very connected to the internet. So we have a lot of computing, edge computings, devices running on the rig itself, which will runs the data quickly without any internet. We run the applications and softwares through the AI hardwares, and the decision will be passed to the users immediately because they have to quickly make a decisions whether they want to drill further into it or not. So those kind of critical situations where the edge computing plays a major role. And there are different types of edge computing, like provider edge, and this has been broadly classified. But when we go through different articles, it might be having a different way of saying what are the different types of edge computing. So mainly this one I've been referring to NVIDIA. This is how they are classifying. So they are classifying like a provider edge, enterprise edge, and the industrial edge. Provider edge is more like it's for the companies like telecommunications, where or for the media companies, or for the service providers, they are using, or they are being called as a provider edge. And enterprise edge is more like data centers and micro data centers, or the traditional the on-premise data centers, where they're using, we call it as like an enterprise edge. And industrial edge is is more like edge servers which is being deployed outside of the data centers, but they run normally uh, as like a unique space, like a cooling, security, and manufacturing challenges, whatever the industries is facing, and they're handling it at their industry levels. Um, Sorry. And there are a lot of edge computings are being used in the industries like and this is not the new concept. It's been developed long back, but it's been utilized more these days because of how the AI chips has been grown up and the AI hardware has been accelerated. So edge computing, it's been used in multiple industries like for retails, smart cities, and automakers, manufacturers, and healthcare, and there are a lot of other industries uses edge computing as well. So at a high level, like for example, in the retails, I'm just giving examples. For example, if you have the retail inventory management to be handled, edge computings can be helpful. Like they can identify how much stocks has been available, and they can easily quickly get an insight out of it. And also in the stores, they might use cameras and sensors, and they can easily identify if there is any theft is happening. And for smart cities, like if you are, I think there are a lot of places we have started building the smart cities, and there also the AI can be used, or as they are using it. So it reduces the traffic congestions. Mainly, if there are too much of traffic flow, it knows how to handle the traffics, and if there are certain areas like if they have the beach or oceans or are close to the rivers, then they can spot the dangerous things and they can highlight if something hazards is been happening in the environments or surroundings. Yeah, and automakers and manufacturers, as I keep on referring to Tesla, they are doing quite a lot of edge computings with their FSD devices, full self-driving automations. So it can do a lot of predictions, and it can do a lot of safety related things, and mainly on the quality side. So it can alerts a lot of things, um, like if the device is not going to be it's not going to be useful, or it might get eroded in the near future. It can easily highlight like what is happening. And healthcare, I think more in hospitals, they are using edge computing for patient monitorings and patient screenings and heart rate estimations and radiology scanners and things like that. And there are a lot of areas they are trying to implement healthcare. Like there are AI models are being built in the medical devices, which is helping in the surgeries, and it provides a real-time visualizations and monitoring during the surgeries as well. So this is all I have. I thought of showing a demo session on Databricks and Palantir, but we have very time limited, but I can walk you through. So let me introduce about what is Databricks and Palantir before I dive into it. So Databricks, it's one of the data platform. It provides a lot of computation to develop all these kind of AI related applications. So in BP, we use Databricks quite a lot. If you are developing an in-house solutions, Databricks is quite useful tool to have it, and it can handle large volume of data. Its computation is high. So we all heard about Spark, Apache Spark. Databricks founder is one of them. They are the earliest starter of the Spark, and when they developed the Spark, they gave to the open source community, and in the meanwhile, they started the company called Databricks. So whatever we are seeing in Databricks, you will see it in the Spark itself as an open source. And there is another company which is a industrial leader in the AI is Palantir. I'm not sure how much you're all familiar with Palantir, because for me, Palantir, I started coming to know in the last 2-3 years. So Palantir is one of the software it's been used in the US defense, US ministry, and so can someone go on mute?
அந்த 3 முட்டையும் இவர் மேல கம்ப்ளைண்ட் வச்சு எடுக்கப்பட்டதுன்னா இவரோட கேப்டன்சி பறி போகும். பட் அண்ணனே எதிர்பார்க்காத ஒரு ட்விஸ்ட். இந்த முட்டையை கொடுத்த கொஞ்ச நேரத்திலே நடந்து போச்சு. யார்
Sorry, coming back to Palantir. Palantir is a software which has been used mainly on the defense, US, UK Army defense side, and the company was there for some more than 17 years, but it was being privately held. So we won't be able to fully understand what Palantir is doing those days. But Palantir is being listed into the public market like in the last 5 years. So mm, there are Palantir application which they have developed. Sorry. So there are a lot of Palantir applications they have developed in the security space for US armies. They have built a separate product called Foundry, which has been used for the enterprise client in outside. So BP has signed a contract with Palantir. I think it's officially announced, so I can say that. And there are a lot of applications are developed using Palantir, and mainly we use Foundry a lot, and we haven't started using for the downstream. So in energy sectors, we have downstream, midstream, and upstream. Upstream is more like wells and subsurface where they go and go and get the oils out from the land space or the sea space. Whereas downstream is more like making use of the oil, like splitting that oil, go through the crude refining process and getting the products out of it. So so these are the areas we are using Palantir a lot, or we are started going to use Palantir a lot. And I'm not sure. I think I have only 5 minutes left based on the time slot. So I may not be able to go through entirely about Databricks and Palantir, but I can just walk you through. So if you search for Databricks, you can go through their Databricks website. So it provides data intelligence platform. I search for Databricks learning. Okay, if you see try Databricks free today, then we can sign up, we can provide our details, and I'll just show you if I have time, but so you will get 14 days trial, like which is like around $400 credit. So you can open Databricks and you can use any of this cloud. Or else if you don't want to use the cloud, you can go with the personal community editions. So which may not be running with the multiple cluster. You'll be having one single node version of the cluster. But if you want to try and running a big data, then you can choose any one of these. So it provides a lot of tools like you can create an ETL like you can extract, transform, and load the job. You can clean the data. You can do some wrangling on the data, and it provides ML as well. There you can build the ML models, and you can also visualize the data. And also it provides a lot of AAP assistant. So even if you're not able to write a code, you can just use the AAP assistant and then ask what can you write this code. And same with Palantir. If you search for Palantir, you can go to Palantir. So Palantir, we have these are the main tools in Palantir or separate softwares in Palantir. One is artificial intelligence platform. AAP is a new one which has been given to the market recently. So it can connect with any kind of open source AAP model like ChatGPT or things, and you can run your AI models based on using ChatGPT on the data sets. And Foundry is the enterprise applications which we are using it, and Gotham is the softwares which are mainly specifically used in the government sectors. Like in the UK, we have a medical organization called NHS. So NHS is the one serves the entire UK medical related things. So during the COVID time, the whole vaccine has been rolled out using this Palantir applications. So all this been built on Gotham platform. And Apollo is more like just deploying these applications, whether you want to deploy it in the cloud, on a private cloud or a public cloud or a hybrid cloud, then Apollo has been helpful in deploying all these solutions. So you can go through that, and if you click on Foundry, you can go through. And the main thing I want to tell you is about the ontology. They all refer to ontology. Ontology is more like it's more like you are creating a data model, or like mimicking what is there in the real time. For example, in the energy sectors, we have refineries. Refineries is the place where the crude is skin is been split into multiple products. So there is a quite large number of equipments are being handled in the refineries. So all these can be mimicked and can be created like a data model. So once the data model has been set up in the ontology, we have sensor devices which connects to all the equipments, and all the data has been transferred through the sensor devices to the data, which has been underlying as an ontology. So once we get the large volume of data, like then we can develop a lot of data products around it. So always ontology plays a major role in developing the solutions within Palantir. So you can click on Learn Foundry, and you can go to Learning Hub, or if you go to Learning Hub, you can click on Start Building Now. So Palantir provides a lot of, so you can go through all these courses, and you can start developing your own application in Palantir. The good thing is, like, if you click on the introductions, uh, you know, it takes about 60 minutes to go through the platform, and you can easily create an account as well. So all these Databricks and Palantir, they are providing free, like a 14 days trial or 30 days trial. You can set up your own account and then explore these things. The good thing is about Palantir is, like, they were being very closed those days. They don't have a community to learn from outside. But these days they are coming as a open source. You can start learning about Palantir. And there are a lot of big industries they are using Palantir softwares. Like I can name a lot of the industries, like Boeing, Airbus, and UK NHS using it, and BP uses it, and they are being used by various industries. Like a lot of startups are using it, like new drone technologies and things like that. So you can start exploring these things. Sorry, I'm okay. If I have 30 minutes, I can set up an account in Databricks, and then we can see whether we are able to set up an account and create something in Databricks. So I'll choose Microsoft Azure, and then I'll continue with this. So how do you want to create a resource, your workspace, and log in? So I'm just going with the free trial. So okay, so I'm using continue to Azure Databricks. So Databricks, they don't have their own cloud, so they use Azure, AWS, or Google. So we can use one of them. So I think this is a subscription they are provided to us, and we can select any resource group. I'm just trying to see if I can use this one. Yeah, and I just want to call it as test workspace. So I'll leave that, and then let's see. I'll click on create. Okay. So it's validating and creating some validation errors. Right, I'll just close my account because it might be conflicting with my account. What I'll do is, like, I'll go and use a Google one. instead of using AWS. Sorry, instead of using Azure. The reason is like in the office I use Azure as well, so it might be conflicting with that. Yep. So I'm going with the 14 days trial. So I'm just going to use my personal Gmail account. So it's providing all the details about the compute, like what I'll be getting. One thing I need to make sure, like after 14 days trial, I need to cancel this. Yeah. So I'm just clicking as start as free. So it should spin up. So I'm getting $300 in free credit. We'll go to that. Okay. It needs all my payment details. Maybe I'll go back. Instead of trying this, let's try with the single compute. So probably I'll go with the community edition. Probably these through the cloud, it might require all my credential, all my credit card details or card details, which might take a little while. So I should have received some email. I clicked on the communication. So yeah. So it will sign an email so I can log in. So community edition is pretty straightforward. You can just sign in and then quickly you'll get the account, and then might tell you the success X GMW.
Treasurer City. 3 BHK ready-to-move and luxury flat near Chandigarh Airport. Call 721 000 00022.
So this is the home screen for Databricks, and I'm just trying to see. So This is mainly for the workspace. And if you go to catalog, there's no data has been loaded. So we have a compute. Compute is more for running our code. So I'm just checking whether we have a compute. So let's create one compute for now. So just go with the default name. And this is the runtime. So there are a lot of Spark latest release are being used. So Spark runs on Scala, which is similar to Java runtime environment. And so let's leave to the default one, 12.2. And we get 15 GB of memory. And there are some default environment variables has been set for Python. So you can write the Spark code either in Scala or in Python, or it can be written in SQL as well. So I'll click on this compute. So it will create a compute for us. I was expecting some data there, but it's no data is available by default. Okay, the cluster is getting started. Go to the ML experiments. It's not there. Okay, let's do one thing. So I'll click on new and then table and see if there are any tables available. Okay, let me drop some files. Is there any sample data we can download? And so I just Google and we have some employees data. So I'm just going to select and then upload that. And let's see if I can bring the data here. Downloads. Create table in notebook, create table with the UI. Just create table in the notebook. So it automatically generates a code for you. So what it says is like the employee.csv file is loaded under this location. This is the location which Databricks uses. They call it as Databricks file store. But usually when you connect with Azure or AWS or Google, then instead of pointing to the Databricks file store, we'll be pointing to Azure Gen 2 or AWS S3, wherever the storage has been linked. And we are saying the file type is CSV. So this code has been written using Python. So whatever you see here, the syntax all looks like a Python. And infer schema is false, which means we are not inferring the schema. And the first row we are calling it as header as false, and the delimiter for the CSV is comma separated. And this is like a normal Spark PySpark code. We are reading the format. We are saying that we are reading a CSV file, and we are setting the schema. We are not getting the schema through the CSV files. That's what we are saying is false. And the first row is header and delimiter. So let's try to run this code. What I need to do is like I need to attach the cluster to it. So we created a cluster. Let me attach that cluster. So I'm just going to run only this node, this section as well, just to see what happens. So in the cluster, we have only one node, so it might take a little bit longer. But when we have multiple nodes, we might have more. So we are seeing this data. But whatever the headers we are getting, that is on the first row. So what we can say here, we have said the first row is header is false, right? We will change that to true. And then also infer schema, so it's not, so it's treating all this as a string. So if you don't specify the schema, then it will be treated as string. So I'll change the infer schema to true as well. Let's run it now. Okay. Now, if you see the first name, gender name, these becomes the column name, the actual column name. And if I open the data frame, it's like a table. Like if you see now, based on the values in the data, it automatically infer the schemas. So now, since we see the start date is having date values, it's being treated as data. Sorry, date type. And same for salary, it's been considered as an integer. And bonus, it's all fractional, so it's been considered as double. And senior manager is a Boolean flag, so it's been captured. So it automatically info the schema. So now we have the data, we are able to read the data. And we can create a temporary view of this data. So this is like using that data frame, we are creating a temporary view called employee underscore CSV. So once that has been done, you can query the data like normal SQL as well. So that's what they're doing here. And you can do whatever you want, like maybe if you want to group by gender and then find a gender and then count of like distinct name, something like that. So it's just we are grouping the employees. Having the column name as first name, and there is a space between first name. Try this. Maybe it may not like it. See if it works. Let me remove the distinct. Yeah. So I think it might be the same name got repeated, but if you see like employees like 424 males are there, 435 females are there, and some of them gender is not being classified. These are things like data is not efficient, so we have to go and correct the source data. You can, what else we can do is like this is normal way you can write a normal Python code or a Scala code or a SQL code to explore the data. There is one other option when we load the data I was saying. So let me go to this again, try to load this data. Create a table with UI. I'm just selecting this one. Let's see what it helps, what it does. There are some of the functionalities is not available in the community edition, but I think once we pay and then go through we are not paying, once we provide the credit card informations and then sign up for a cloud-based service, you might see a lot of other functionalities. So this is more like you can preview the table before you create it, and then I think you're creating this table using the Notepad. As you see, this data is small, so you're not seeing much efficiency in what we are doing, but this is the same applications we are using where we are handling like petabytes of data. So as you know, in energy sector, if you know BP is there for more than 30, 40 years, if my understanding is right. And they have a quite large volume of data coming and we are handling it. So all these data have been heavily managed within Azure, AWS, a lot of clouds. But the computation we use in my areas, we are using Databricks. So Databricks can handle that much large volume of data. So whatever you see here, it might be a small data set where we are playing up, but the same can be applied to a large volume of data as well. There are a lot of other functionalities which is not available here. It shows very minimal, but once you sign up with the cloud service, then you might see other functionalities which you can explore. So I'll leave it here. If you have any questions, you can ask me.
Dear participants, you can raise your queries at this time to Mr. Shivaram.
Good evening, sir. Edge computing in different industries. It was very interesting. Thank you, sir.
Thanks, Shivashankar. Do you have any questions or anything you want to know about what we do or related to the topic? Yes, sir. Hello. Yeah. Sorry, sir. Your voice is not audible. I'm not able to hear you properly.
Good evening, sir. Are you audible, sir?
Sorry, sir. Still, your voice is breaking. I'm not sure whether it's only for me, but your voice is a little bit breaking.
Yes, sir. Mr. Murugesh Pandian, your voice is breaking for me also. Kindly check your network. Thank you.
Good evening, sir.
Yeah. Good evening, madam.
Sir, can we develop DCNN in the using this model, sir? Like, can we use this for developing GCNN model?
Can you tell me what is that GCNM refers?
For deep convolution neural network, if you want to develop
Yeah.
models, is it possible?
Yeah. Yeah, you can do it. Like so, Databricks allows ML modeling. So sorry, maybe I can show my resource, but let me share the screen. Back again. I'm not going to show the data, but I'm showing the interface. Like so, if you go to the machine learning, this is not there in the community edition. But if you sign up for a Azure or any cloud-based service, it might give you. So where you can create your training models, and you can write normal Python code, and there are some default models are also available. You can use that, and you can play with the experiments and then run through the models as well. So anything in so open source, you can bring it into the Databricks and you can run it through Databricks. Since it provides larger computations, you can play with the large volume of data. So only thing is you might need to have a subscription for it. If the trial is not sufficient, then you can go with the paid version, but it may not cost you a lot. And you can set the computes to stop once you worked on it. So you can go and stop the compute after you finished it, or you can set up something like this is by default, every 30 minutes the compute will stop if you're not using it. So those kind of settings are available. So if there is no inactivity 20 minutes, then you're not paying much on the compute. You might be paying very minimal. But to answer your questions, yeah, you can run through the deep neural network model using the ML functionalities, whatever you are seeing here. Yeah.
Sir, can
And
we
there are
get
a lot of
GPU computing nodes?
Sorry, madam, what do you say?
Can we get GPU computing nodes?
Yeah, you can get, yes. But sorry, you may not see like a GPU on your end when you are seeing it, but the compute, whatever the infra has been fully managed by Databricks. So I don't think we can go and say what we are using as GPU or not. But to be honest, like I don't think you'll be getting GPU. It's more like whatever the class, the service which is being provided. It's all like a standard CPUs only. I know it's not easy to get a GPU space and then run it. What you can do is like you can go with NVIDIA and then try and see if they are providing. I think they are providing few these kind of workspace where you can run the model, and they can offer the GPUs on the cloud. I haven't tried it, but you can explore on it.
Thank you so
But
much
whatever
for
the
the
yeah. Whatever the clusters you are seeing, it may not be GPUs, it's only CPUs only. Yep.
Good evening, sir.
Yes, sir.
Sir, my question is connected with the previous question. So when you are working with the Google Colab, so there also we are having GPU and TPU allocation, no, sir. So depends upon the program. The GPU can be allocated, no, sir. Is that right?
Sorry, sir. Can you repeat it, please? Your voice is not fully audible for me.
Sir, actually, I
I'm
am in
hearing
journey.
some.
I am in journey. Sorry for the inconvenience.
No problem.
My question is related to the earlier question, sir. Google Colab is also online platform now, sir. Suppose
Yep.
when we are running this use deep learning models, so they are
Mhm.
also having a possibility to allocate the GPU as well as TPU.
I'm
My
not sure
question is,
whether.
what is the main
Yeah.
difference between the Databricks and Google Colab for
So
running a
yeah.
particular deep learning model?
Mhm.
Is it clear, sir?
So
Question is clear?
yeah, I can yeah, I can get your questions. So Databricks, we can run the models, but when we deploy the models, it's going to use the Databricks compute available. But as of now, I understand we don't have control in selecting whether we want GPUs or CPUs, sorry, GPUs or TPUs. It's more like how Databricks is managing efficiently on that. But maybe if you have the options in Google or other service providers, it's better to try there. Or you can run between both of them and then see where it's efficiently handling it better.
Thank you, sir. Thank you.
Thank you.
Participants, any more queries are there? Okay, I think we can end up the session with Mr. Shivaram. So let us convey our thanks to him. Shivaram, very sincere thanks to you. Your session on the AI and AI accelerators and the demo session all were very useful to the participants. Hope they would explore the things under this from today onwards. More about this, they will be gathering knowledge. At this juncture, I would like to inform Mr. Shivaram Veerabagu is an alumni of our college. So it's a very proud moment for all of us as a faculty to have him as a resource person in this FPP. Once again, I convey my sincere thanks to Shivaram. Thank you, Shivaram. Thanks a lot.
Thank you, madam. Thanks, everyone. Thanks for your time. I'll see you again in some other sessions later. Thank you all. Have a nice day. Bye.